Good afternoon to everyone. This is our first introduction part to the GIS course, introduction to the GIS course. In this course, I will give a lecture about the introduction to the GIS, all the necessary things that you need during entire this course. Is this visible, my screen, just for check?
Yes, Roger.
Okay. As I said, this is a first lecture, or let's say this is the first chapter of our course. Our course have two chapters. The first chapter is a theoretical framework, and the second chapter we are moving to the program. I think by next session or by coming lecture we are going into the program, but this lecture, this is just an introduction and it is a theoretical framework for you. There are some important issue there. You don't need to be memorize them. Try to learn them. It's not difficult. They are very easy things, and I'm sure that you know most of the things. As a very brief, I can say that the aim of this course, the main aim of this course, we will try to provide actually an overview in a comprehensive way from a geographical information system and GIS. At the end of this course, I will expect you first of all to understand the basic thing about the GIS, including the structure, concept, and theory. Besides that, I believe you are able to work and apply a variety of the GIS operation at the end of this course, and you are able to work with a component, different data type in a GIS. You will see what is coordination, what is coordinate, what is projection, why it is important, and why you need to use them. And also, since we will expect to have a final project during this, let's say, entire course, you are able to first of all analyze, understand, and prepare at the end present a final project. In this course we do not have any final and midterm exam. We will have some let's say weekly or session based assignment, and we are not have any final or any paper based examination. You are supposed to submit your final project. We are we are planning to have those events in 3rd of September or even earlier days, because I want to leave you to work with your other course or other project and enjoy your let's say holiday. So maybe there are you have many different things right now in your mind. One of the thing is geographical information system. So what is the information and what kind of information we are going to work with it? But before it, also maybe it's come to your mind that what is data? So if it is information, then what is the data and what is the relation of it to the GIS? What is the application of the GIS, advantage and component of the GIS? The important things about the data and information, first of all, you need to understand what is data. Data, it can be a set of qualitative or quantitative variable. It means that it could be a fact, a word, a image, a set of measurements, such as the number, but at this format, they are very raw and not understandable. For instance, I put a 17 here. If you just care about 17, it is nonsense for you and it is raw. You don't know what is 17. Is this, let's say, a unit of the length, such as centimeter, millimeter, or inch? Is this unit for a weight, like a kilogram, ton, grams, or for a temperature, 17 Kelvin, centigrade, Celsius, Fahrenheit, or many other questions like 17 watt. The important things when we get this, let's say, set of value, we need to convert it to something meaningful for us. We need to put something at the end to inform our audience. So we can say that we are working with 7 people, so you understand that this 17, it is a people. We are talking about 17 people, or I am working in an area with a temperature of the 17, so you understand that I am working almost in a moderate climate. So you need to transfer this data to the information. This is the first fact for us. As I said, information system, first of all, let's also say what is a system. A system, if we want to say we understand what is the information, for instance, this map in the right corner of the screen, you will see that provide you information about the pandemic of the COVID-19 through the world map. You will see the most dangerous or most red part, or the place that much more secure in comparison to the other continent. It's provide you information as such, a set of information, then you are easy to decide. You are easy to decide and easy to recognize. Sorry, it's something to my eyes. So now, what is a system? System is a person, like your body. Let's give example. Your body itself is a system because have some member, they are work with each other and handle your body, and you can live. So you have an organ and you have member, so they are working in a process with a very organized manner, and they have an aim. What is the aim? Your aim of the body is a living it experience and learn new thing. So system also same thing, a computer, all of them. Our course is a system. We have an aim, we have a member. I am one member, you are other member. We work together, we have some activity, process, and we have an aim at the end of the. I'm coming to the, let's say, this part. We have an information system, and this system aim to process onto the data in a very organized manner, and during this process, which is could be automatic or manual process, we are deliver or we are transfer, let's say, data to the information. So this is an information system. Why we need it? Why we need an information system? Let's give a familiar example from your, let's say, architectural career. At the beginning of each design course, They will give you some data about the site, about the content of the site, about the, let's say, program of the design, and you are start to analyze. You are visit the site, then transfer the data into the useful information, and then make some map, some land use map, accessibility map, different site sort of analyze in order to support your decision. Which building should be located where in your design process, then what should be the orientation of the building, which part should be high rise or low rise, which part should be open space, which part should be have a good view. So this, let's say, information that you are create from the entire site, from the raw data, help you to support your decision. So in an academic way, we say decision support system. You are every day actually use it. Maybe you know that. For instance, imagine you are going to the, you want to go to the shop, you want to purchase something. Based on the information that you have, start to decide from the moment that you leave your house until purchase and come back to the house. Imagine when you are across the street, you just watch surrounding, analyze the speed of the car, then decide that you are able to cross the street or not. So these are the information which, based off that information, your mind start to decide. And with those information, your let's say decision could be support. In a, let's say, in a very let's say business model, we need to take a big decision and we need to solve a big problem. That's why we need to work with a more complicated information and different sort of the data. That's why we need, let's say, interactive software-based system, which intend to help us to make a decision, a better decision accordingly in order to solve problems. Is there any question up to now? Is it clear, everything?
Yes, Hocam.
Yes, Hocam.
Okay, so let's continue. We can say that geographical information system, or GIS. The geographical part refer to the spatial data. You are, since you are architecture, you are fine with this part because you are every day work with a spatial data, with a three-dimensional model. We have a coordination system, X, Y, and Z. We have a Cartesian system, again, X, Y, Z, based on the local on the paper. We have information, or let's say database. Your database is can be a piece of paper when you are going to the site. Definitely when you go to the site analysis, of course now in the pandemic maybe you didn't have such experience, but before pandemic definitely you remember, you go to the site, you check the building and write the information of the building on the paper. You say, for instance, building number 1 is a 4-floor height. It is a concrete structure, partially residential or mixed use. There is a grocery shop, etc., etc. Here, we are not taking this note or this, let's say, data or information in the paper. We just keep them into the different bunch of the data set let's say, programs such as Access, DBase, Oracle, Excel, the easiest one, Notepad also a kind of the database, and MS Access. We have a system, our system in terms of the computer could be a network cloud computer, or in terms of the people, our system can be our member of the project. These are also considered as a system. I just want to give you a very brief information about the GIS story. The Geographical Information System first time acknowledged by Roger Termilson during 1968 when he published a paper, A Geographical System for Regional Planning. He was the, let's say, established the first, let's say, operational GIS in Ottawa, in Canada, to, let's say, keep and analyze the federal Department of Forestry and Rural Development. They use this system to analyze those things for a Canada land inventory. This person from that time known as a father of the GIS, and he believed that it can be worked. There is a common ground actually in a GIS between the many different disciplines. If you remember, I just stated that previous session, GIS can be used between different field and discipline, because many fields use a spatial analysis. So this spatial analysis technique, the common ground or common base among a different discipline. We have 1,000 GIS definition, but I believe that all of these definitions have some common keyword. These keywords include collection or capture or input. Let's explain in this way. First of all, you collect some data. You need to store it. You need to later retrieve it or call them back, and then analyze on them, and then make a report from them. So as you can see, a collection, capture, or input, it is common in all of them, or a store event. Then you are storage it, you put it into the data set or database or storage. Then you retrieve all them, you manipulate them, or you are recall them or transfer them. And after that, you start to analyze them after you call them and convert it to the useful information, which is the output of a study. Don't memorize any of them, just try to understand the concept. In this course, we are not memorize anything. We just understand. There are many other definitions I put here, but as I say, and as you can follow, all of them are same and following the same and provide the same things. And these are the reference for those who wish to going into the deep, and they are the most important book for GIS and most important reference and bibliography for let's say a GIS definition and GIS. But I just try to make it this definition. GIS is a system of the integrated computer. It's the integration of the computer-based system. It is a tools for end-to-end process. What does end-to-end process from starting point, which is a capture, until to the display, the output, everything can be done during this GIS. So let's say a system integration, computer-based tools for end-to-end processing of data using location of the Earth. It means that we are using the spatial data for interrelation, support of operational management, decision making, and science. So this is I think, very comprehensive. It's include the decision system support, include the system integrate, computer-based, it include end-to-end processing, and include spatial data. Now, let's make it in a very easy diagram. As you can see, again, these 5 components, it's there. We have some data input, then our data going to the database. After that, we write some query. What is a query? We call them. We ask them this data. We start to questioning this data. Then we work on it, we manipulate on it, we transformation on it, and analyze on it. And at the end, we make an output result and display, and we gave to the, let's say, end user. As you can see, the important part is the data. If you don't have a data, you cannot do anything. If you have a wrong data, also you cannot do anything. So data is the very, very important part of the study, almost 80% of the process. And if you don't have even the data, you cannot start the process. So data is very important for us. Just 15%, it's including the data management or manipulation or transformation or analyze part. And just 5%, it's output and result that maybe you just stick into the wall and people just see it. But the important part is the data. If you don't have data, you cannot do anything. You cannot take any step forward. I put again this diagram for you. We have a different bunch of the, let's say, spatial data. It can be coming from a map, it can be coming from a table, it can be coming from the list, it can be coming from a GPS, photogrammetry, from the image, from the, let's say, survey, field survey. So all this data can become here. We have a database, like a box, everything go and collect there. This is this 15%. And the last percent, which is report or output, we just make, let's say, hard copy, digital copy, or screen queries, which is the 5% or our work result. Okay, based on the coordination, which is X, Y, Z, or let's say based on the spatial, we have the 6 important methods of the data collection. The first easiest one is a GPS or global positioning system. When you just move anywhere under the satellite, you are able to record the different spatial points and add some note in front of it. Either a location, either a specification, anything. We have a digitalization. Definitely you done this digitalization, I believe. They gave you a map, the cadastral map, the scan one, into your computer, and you just take it into the computer and start to digitalize it. You go over the line and make it digitalized. This is a digitalization. Or you can also able to draw, maybe you have some sketch tablet, then you are start to digitalize your sketch and make your, let's say, raster and vector data. I will coming to raster and vector. I will explain what is the raster and what is the vector. We have a remote sensing, as coming from its name, it is based on the remote and from a distance. We have a satellite, the satellite capturing the earth. There are different sort of the satellite for a different purpose with a different sensor. They can reflect and observe different beams, or let's say wave, electromagnetic wave to the earth, and then store the reflection of it from the earth and accordingly make a sense. This is called a sense, satellite sense, which is based on electromagnetic. And then we are able to work on that part. We are able to analyze those electromagnetic image and then start to convert it to the information. We have a photogrammetry. Photogrammetry is a more typical one with the use of the UAV or drone. They start to capture the earth. In compared to the satellite, it is in a low altitude because the satellite one is almost above the atmosphere, but the drone and this also airplane, which is equipped with a camera for a photogrammetry or for aerial photography, they are in a low altitude, they are fly and then capture the earth, and each of these picture called a mosaic, and then these are have an overlap onto each other. They put this overlap and make a big, let's say, image, and then start to transfer it to the real map. And this is about photogrammetry. We have a scanner. You know the scanner, I don't want to explain it. We have it in a bigger scale, smaller scale. You just can transfer the old map in a big size or a small size to the digital format. And at the end we have a field survey. Definitely you done it in your Art 190. It could be done by leveling, by theodolite, by total station. We have a different program. Even we have nowadays a laser scanner, which you can put it and start to observe and make a cloud point, and then you are able to transfer it to the map. These are the, let's say, 6 main methods. Now, up to now we are speak lots of things about GIS, but what is the application of it? What is the application? Imagine you want to not always think as an architecture, actually think as a business also, because all of you, if you want, after graduation, you want to make a money out of this. You want to be a businesser. Now, imagine you want to, very simple example, you want to open a grocery market or supermarket. Where is the best place for such an investment? Or in, let's say, in our city, let's say in a Famagusta, since all of you live at least for a time here, where is the best place in your idea? Just think about it. If you have money and you want to just open a supermarket, most of the people, they are just directly go to the in front of the university in that, let's say, road, they just open a supermarket or either in a behind road. That's why we have right now, I believe that we have 6 supermarket there in a EMU square, in that road or in the behind road. There are also 2 or 3 roads. But this is a very wrong investment, because everyone thinks that, okay, there are students here, there are people there, so let's open there. But in fact, we have right now 6 or more or less supermarket there, and right now, due to the pandemic, those areas become, let's say, not uninhabited, but not like before. We do not have that amount of students. We do not have anymore 17,000 of the student there. There are less amount of it. The logical thing, you need to go to the GIS and start to analyze where is the high density in the city, and then where is the place with the less amount of supermarket or even no supermarket. There are just few points with this situation. Then you need to go there. That is the correct investment. Okay, you are not able to invest by chance, otherwise you sink. And if you open there, since there is a 6 supermarket available, so the income will be shared between 6 other and you. So it is not a win-win. Therefore, this is one of the, let's say, application of the GIS, one of the simplest one. Or same thing, you want to open an exchange office. Again, you should know that where you need to open an exchange office. This is very important. You need to open it at the proximity of the CBD or central business district, or at the proximity of the tourist hub. Not everywhere useful for opening an exchange office. If you open it, let's say, in a dense people, in a dense neighborhood, it is not useful, because the dense neighborhood with the local people, they are not dealing with the exchange. They are not change their money from, let's say, Turkish lira to the other currency. But if you do it in a tourist center, or if you do it in a, let's say, central business district, your chance increase. You want to looking about the accessibility, how many green accessible place we have within a, let's say, 500-meter distance, visually and physically. You are able to use this thing. As a military, you want to know where is the best place to land a helicopter, or to deliver parachute. Or as a security, you want to, let's say, transfer a very important person from, let's say, airport to the parliament. So you need to know that which one is the less traffic road, which one is the fast, which one is the securest one. So all these and many, many other things could be do inside the GIS application. But let's go to the one of the first application of the GIS. This man, Dr. John Snow, he knows as a father of the modern epidemiology. And I believe he is first user of the GIS. Of course, we say that Roger Tomlinson invented the GIS. Of course, in 80s, 50 or some, there is no computer like today, and there is no GIS definitely. But these people, this man actually, this doctor, used a GIS somehow to solve the problem, to solve this epidemic there. in London during the 80s, 50s was a cholera problem. And this cholera was poorly understood. The people thought that this is coming through the air, the pollution or the virus through the air. Because of their poor understanding. This man take the London map in the hand and start to investigate. Start to put a dot where the people die or where the people pass away. Start to put a dot on the map. For instance, here they have 10, here they have 12, here they have 5, accordingly and accordingly. And it start to investigate and draw this diagram. You notice that in some area density of dot is too much, but in other place is a less and even very less, and even in some area there is no point. He started to think that maybe the water pump is polluted, that the people who drink from this water pump, they're dead. So there is a Broad Street water pump. So he closed that one. They closed actually that water pump, and the pandemic was finished. He just used the GIS as a first user. He don't know that this is a GIS definitely, but this is the, I believe, the first user of the GIS. And based on this hypothesis, he solved the cholera outbreak in London. If you want to looking for a knowledge-based discipline for a GIS, we have a different bunch of the application based on the discipline. As a computer science, we have a graphics visualization, database, system administrator, and security, all those people involved in this discipline. In terms of the geography and related discipline, we have a cartography, geodesy, photogrammetry, landform, spatial statistics, and etc. In terms of application area, we have a public administration, geology, planning, mineral exploration, forestry, marketing, civil engineering, surveying, criminal justice, and site selection. These are the different disciplines that have a common point on a GIS. All these people can be worked in one point under the GIS umbrella. In terms of the, let's say, real application, the things that definitely you hear, since especially you are from architecture department, GIS used in the city information system, forest information system, highway information system, land information system, land registry and cadastral information system, logistic information including vehicle tracking information system and internal security information, traffic information system. We have even a campus information system. Definitely you saw it because we have also in our campus, there is an interactive map. If you just open it, you will get a different information about our campus. Again, earthquake information and map information system. There are also different other IS or information system. As you can see, I put some of them in these diagrams, such as mine information system, soil information system, and infrastructure, population, tax information system, and there are many more and many more. As I said, application of the GIS we have in the real term, most of them, 80%, could be done by a local government. A significant proportion could be shaped by a state government. Business owner use a GIS for a variety of the purpose. Military and defense and scientific and researcher, all of them are involved, or all of them employ a GIS, and all these people are the GIS user. We have also a GIS. This is this data gathering from a municipality of the Famagusta. GIS could be also applied in a municipality, such as a city information system, illegal containment inspection, and numerical addressing management, which is missing in our city, infrastructure management, which is also again somehow missing in our city. As an example, for instance, let's say electric department coming and they dig the street and put their own electric line, and then they cover it, coat it, and a few weeks later, water department coming and dig again same area, and they put this time a water line. So this is the mismanagement of the infrastructure. We have also numerical addressing management, which is a missing here. You are mainly try to addressing the friend or people by explain some, let's say, legible things or landmarks. We start to guide people by using, let's say, bank or park or a supermarket. You will say that if you see that supermarket, then turn right, turn left, then you will find that building or those buildings. However, in other country like Northern America, they just, this is totally work in a managed way. For instance, they just say the street number and a flat number. With two numbers, they are able to guide people to the destination, which is missing here. Again, urban information management.